In this problem, it says if 2 pounds of apples cost $5, at this rate, how much will 17 pounds of apples cost? So we can go ahead and set up a ratio table to solve. In this problem, you're comparing the pounds of apples, so I'll put LBS for pounds, to dollars. In this problem, it says 2 pounds of apples cost $5. Our target is to find out how many 17 pounds cost. So 17 has to go on the top with pounds. So we're going to go ahead and let the ratio table do our work. We're going to go ahead and double 2 to make 4, and we're going to double 5 to make 10. I'm going to double again to make 8, double 10 to make 20. I'm going to double one more time to get to 16 on the top and double one more time on the bottom to get to 40 on the bottom. I see that I'm 1 away from 17. So I'm going to go all the way back down to my easy numbers, and I'm going to say, well, 2 divided by 2 makes 1. And if I do 5 and I divide by 2, it makes $2.50. And some of you might want to say 2.5, but that doesn't make sense with money. We have to put the 0 on the end to make it $2.50. So now I can go ahead and do 16 plus 1 to get to 17. And I would add together 40 plus $2.50. So 40 plus 2 makes 42, plus the extra 50 cents. So 17 pounds of apples would cost $42.50. In this problem, it says if 20% off a shirt is $8, what is the cost of the shirt? This is a percent problem because we do have a percent. So recall that percent of the whole equals the part. Now you have to determine what you have. It says we have 20%, so that goes under percent. Of, do I know what the whole shirt cost? It says no. What is the cost of the shirt? So that's what's missing. Equals the discount off, which is $8. We can solve this one of 3 ways. I can go ahead and set up a tape diagram. One, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal pieces. I do not know what the whole tape diagram is worth. I do not know what the 100% is. Remember, percent in this is on top. In this case, the dollars are on the bottom. I do know that 20% is $8. But 20% is 2 equal pieces, so I have to divide each piece, and that makes 4. 4 plus 4 makes 8. So each piece is worth 4. Since I have 10 equal pieces, I take 4 and multiply it by 10 to get 40. So the total shirt cost $40. I can also use a double number line to solve. If we set up our double number line, we have our 0 and our 0, and we have our 100. We do not know what the whole amount is, so we do not know our 100%. We do know 20% is 8. So since percents are on top, 20 is 8. I can go ahead and divide by 2 to get to 10%. Divide by 2 makes 4. Now I know I can do 10 times 10 makes 100. 4 times 10 makes 40. So my shirt would cost $40. If I wanted to do this in a ratio table, I can compare a couple different ways. I can do 20 out of 100. And then since this is the part, it would go on the top with 8. Or I can say, well, 20% is 8. So this is my percent. This is my dollars off. So I'm trying to find out what 100% of my shirt costs. I can go ahead and double it, 40 and 16. I can double again, 80 and 32. And then I can see that 80 plus 20 is equal to my 100. So 32 plus 8 is equal to 40. So 100% of the shirt is, again, $40. In this problem, it's asking us to find both unit rates. It says 4 gallons of gas cost $16.20. What is the cost per gallon? And then what is the cost per dollar? So I'm going to go ahead and set up one ratio to solve both. And in this case, you might need a calculator to do some final calculations. We're doing gallons per dollar. And we know that 4 gallons is going to cost us $16.20. We want to know what 1 per gallon means per 1 gallon. So I'm going to go ahead and put the 1 on the top, and I'm going to say, well, if I divide by 4, 4 divided by 4 is 1, and I have to do 1620 divided by 4. And if I didn't know how to do that, now I could pick up my calculator, making sure that $16.20 divided by 4 makes $4.05. So if 1 gallon of gas costs $4.05, and I want to know what the cost per dollar is, which is an unusual thing to do, but sometimes we have to find it. That means this time I have to have a dollar on the bottom. So I would divide $4.05 by $4.05, because any number divided by itself makes 1. So I'm going to take 1 and divide by $4.05. So in this case, we're going to go ahead and see that, I don't think that's right. We're going to take 1 and divide it by $4.05. In this case, it's so close to being 1 divided by 4, and there's 5 cents, so it's going to be about 25 cents. You can use your calculators. I don't have one with me. So if I was to look at it, it would be $4.05 per gallon is 1 unit rate, and approximately I could get I shouldn't say 25 cents, 0.25 gallons for $1. So I wouldn't get much gas for $1. In this problem, it says if there are 16 ounces in a pound, how many ounces in 2 pounds and how many in 3 pounds? Use a table to show your results and graph them on the coordinate grid. So we're going to go ahead and set up a table, and that would be a ratio table that we're going to set up. Oops, sorry. And we're going to compare ounces in a pound. So we're going to compare ounces to pounds. I'll use LBS for pounds. There's 16 ounces in 1 pound. I need to find 2 pounds. So in order for me to do that, I double 1 to get to 2. Double 16 makes 32. So there's 32 ounces in 2 pounds. And to get to 3 pounds, I would add these two together. 1 plus 2 makes 3. 32 plus 16 makes 48. And then your job is to go ahead and graph this on the coordinate grid. So in this case, if you recall that we've talked about the fact that what goes in, it goes along the x-axis, what comes out goes along the y-axis. So on the x-axis, we're going to be looking at ounces, and on the y-axis, we're going to be looking at pounds. So we'll go back to our table. Our ounces are 16, 32, and 48. So we're going to go ahead and count by 16s from 0. We're going to do 16. And then we're going to do 32, and then we're going to do 48. Along our y-axis is our pounds, and it just goes up by 1, 2, and 3, so I can do the same. 1, 2, and 3. And we plot our ordered pairs, and if you remember, if you have 1 or 16, that's comma 1. 16 and 1 go together. 32 and 2, 48 and 3. So we're going to plot these ordered pairs. 16 and 1, 32 and 2, 48 and 3. And what will happen is it will form a nice straight line. And if you remember, we can predict what perhaps 20 is. If we go in between here, we can come up to the line and find out how many 20 ounces would make. And whatever hits our line is a solution to our table. In this problem, you have a picture on your study guide that shows a border of gray tiles, and there are 6 of them out of 18 tiles total. And the first part of this problem says, what is the ratio of gray tiles to white tiles? Well, from the top, we can see that gray tiles is, in this problem, it says that gray tiles, you have a picture of gray tiles, there's about a border of 6 of them, and there's 18 tiles total. This problem is asking you for what is the ratio of gray tiles to white tiles. Well, we can see there are gray tiles, 6 gray tiles. So it'll be 6. If there's 18 total, that means that there has to be 12 white tiles. And if you notice, 6 plus 12 makes 18. So it's 6 gray tiles to 12 white tiles. Then it asks, what is the ratio of gray tiles to the total tiles? Well, we already have that. It's 6 to 18. Now the last problem says if the total cost of the gray tiles is $9, what is the unit cost per gray tile? So it's saying that if we go ahead and set up a ratio table for this, we know we're comparing the dollars to the tiles. And it costs $9 for 6 gray tiles. So we're going to go ahead and work our ratio table to find the unit cost. And if you remember that unit cost means per one. So we want to know what the cost is per one tile. So some of you may say, well, you can divide 6 by 6 to get to 1, but that doesn't make any sense to you because you don't know what 9 divided by 6 is. So we can go back and we can see that 9 and 6 have 3 in common. So 9 divided by 3 makes 3. And 6 divided by 3 makes 2. So now we have a little bit smaller number to deal with. So 2 divided by 2 is 1. And if I cut $3 in half, you would understand that half of $3 is $1.50. So it costs $1.50 per tile.